Okay, so welcome everyone to today's tutorial. We are looking at questions to do with scalars and vectors. Okay, so this was tutorial sheet 2 of 2023, and we wanted to solve some of these questions. Okay, so this is a makeup class to the physics class that we didn't have last week on is it Saturday? Okay. So we want to have a makeup class of that, and so some questions from this tutorial sheet. Okay. So previously in our last lessons, we learned how to resolve vectors into their components, and we learned different techniques or different languages that they use in describing these vectors. Okay. So today we are just going to apply all those concepts that we've been learning to solve some of these questions, okay? So we have the summation of vectors here. We also have the difference of vectors, okay? And we'll also see how we can find the what? The resultant vector, okay? Even its magnitude and also its direction, okay? So we start from question 1 there. If you have any question on whatever I will explain that you do not understand, please feel free to ask. Okay, so let's look at question 1 here. They're saying vector A has a magnitude of 10 units and makes 60 degrees, okay, with the positive x-axis. And then vector B has a magnitude of 5 units and is directed along the negative x-axis, okay? And then find the vector A plus B and the vector A minus B, okay? So there we are just simply finding the resultant vector, okay? So how do we find the resultant vector? We have to resolve whatever we've been given here into their components. So if I have my x or y plane here, okay? I'll have the first vector, which is 10 units, and then it makes 60 degrees with the positive x-axis. So the positive x-axis is this guy here. And then the negative x-axis is this one. The positive y is that. The minus y is that. Okay, so we are going to write this vector here, which will be 10 units long. Okay, 10 units long. And then the angle that it makes with this positive x-axis, we've been told that it is what? 60 degrees. Okay, so we can resolve this vector into its component. And then the other vector that we've been given here is the vector B, which has a magnitude of 5 units and is directed along the negative what? X-axis. Okay, so along the negative x-axis, it means it's just within here, this axis here. This is a negative. So we have this one, which is 5 units long. Okay, so what is the angle when this vector is along the negative x-axis? Okay, so we said we always count our angles, okay, or measure our angles from the positive x-axis. So I'll start from here all the way up to here. And we see that whatever angle is formed here will just be what? 180 degrees, okay? So we have the angle, the magnitude. It means we can resolve this vector. Even here we have the angle and the magnitude. We can resolve those vector, and then we'll be able to find our A plus B and our A minus B. Okay, so let's find those resultant vectors now on the board here. Okay, so let me just redraw that diagram. So it is like this, and then you have vector A here, which is 10 units long, and then we have a 60 degrees there. Okay, then we have another one that is along the negative x-axis. Okay, we said this guy here was vector B, and it was 5 units long. And then if you measure the angle from the positive x-axis, to just be what? 180. So let's find the resultants of this. So I'm going to come up with like a small table here. Okay. So this will be our table here. And then I'm going to write this will be our x component. And then this one here will be our y what? Component. So this is what we have here. And then we have the vector A here, and then we have the vector B there. Okay, so what are we going to do here? We are going to resolve this 10 and this minus 60 degrees. Okay, so we said the part that has the angle between one of the axes of this x or y plane and the vector is the one that gets the cos. Okay, so if we resolve that 10, it's going to be like this. Okay, so this is the 10 here. We resolve it into the y, then we resolve it into the what? The x. So the part here that is down is going to become 10 cos 60. And then the part that is going up will just be 10 sine 60. Okay, so the y component always goes with the sine, and then the x component always goes with the what? With the cos. So this will be 10 cos 60. Okay, and then this will be 10 sine 60. So what is 10 cos 60? Okay, so you get your calculator, and then you just simply punch in. So it will be 10 multiplied by cos 60. It gives me 5. Oh, why am I writing 5 there? Okay, so that's 10 cos 60, it gives me 5 here. So this here will be equals to 5. And then what about 10 sine 60? So 10 sine 60, it gives me 8.66. So I'm going to write 0.866 there. Okay, and then for the b, we do the same. So for the b, our x component, okay, I'll use blue here. For the b, our x component will be this guy, the same guy here, will be our x component. Then our y will be that one there. Okay, so we're going to write 5 cos 180. And then here we're going to write 5 sine 180. Okay, so what is 5 cos 180? So 5 cos 180 is going to give you a minus 5. So this will be a minus 5. And then here, 5 sine 180 there is just going to be 0. So here we're going to get 0. Okay, so we've gotten the components of this A and the components of this B. Okay, so now the first question here, they were saying what? Find A plus B. Okay, so what will be your A plus B? Okay, you're just going to add these two vectors here. So this will be our x component of the A plus B. This will be our y component of the A plus B. So we're going to say A plus B, okay, is equals to, you add the components of the x, okay? So the components of the x will be 5 plus minus 5. So this will just be 0, okay? And then we say plus, what will be the components here when we add them? It will be 8.66 plus 0. Okay, so that will just be 8.66. Okay, so it means I should write this in this form. Yeah, you write it as a vector. Okay, so you write it as a vector. So you say the x component was 0, and then the y component will just be 8.66. Okay, so this here will be our A plus B. Okay, and then how do we find now our A minus B? Okay, so our A minus B, how are we going to find it? Okay, our A minus B, we're going to find it in this way. So notice that in this A minus B, you have a minus on the B. Okay, you have a minus on the B. So what are we going to do? We are going to add a minus on all these B's here. Okay, on all those components that are under the B. Let me do this. Let me get Y. Okay, so we notice that this is minus B, but here what we have is B. Okay, so what are we going to do? We are going to add a negative, okay, or we are going to multiply by a negative throughout. Okay, so if I multiply this by a negative, I'm going to get what? I'm going to get positive 5. Okay, so I'm going to write minus B here. If I multiply the 0 by a negative, it still remains a 0. Okay, so now let's add the x components here. So this is A, and then this is minus B. Okay, so A plus 5 is just going to give me 10. Okay, and then here it will be 8.66 plus 0 is going to give me 0.66. Okay, so this one here is our A minus B. That one is our A plus B. Okay, so any questions there on how we are doing? Okay, no question. Let's look at the second question, which is on a similar concept. But there now on the second question, we'll add the idea of finding the direction, okay, and the magnitude. So we know that the direction here, okay, this direction here is just the angle. Okay, when they say direction in vectors, they just simply mean the what? The angle. Okay, and then the magnitude. Okay, we know how to find the magnitude. Okay, so let me write the two formulas that we are going to use. So the magnitude of a resultant vector is just equals to the x component squared plus the y component squared. Okay, and then you take the square root like that. And then the angle is always equals to the tan inverse of the y component divided by the what? The x component. Okay, so these are the two formulas that we are going to use on that question. Okay, so let us look at this question now. So we are on question number 2 here. And here we've already been given some sort of a diagram, right? So it will be very easy for us to find whatever we want to find. Okay, so the question is saying in figure 2.1, which is this figure, find the direction and the magnitude of the vector sum A plus B, the vector difference A minus B, okay? And then we have the vector difference again, B minus A. So for us to find all these A plus B, A minus B, we have to resolve these vectors that we've been given into their components, okay? So now notice that the angle that you should always use is the one from the positive x-axis, okay? So if I go to this vector A here, it has 30 as its magnitude, okay? But what is the angle or what is the direction from the positive x-axis? Remember, this is the positive x-axis here. So we start from here until we meet the vector. So what is this angle here, okay? So this angle, we notice that it ends here, and then in front, up to we meet the negative x-axis here, it is 25. So we know that if we had a full semicircle like that, that would be 180. Okay, so what would be the value of this angle? To just be 180 minus the 25. Okay, so that angle will be what? 180 minus 25. So 180 minus 25 to give you 155 degrees. So it means when resolving this A, we are going to be using what? 155. Okay, and then okay, and then this one here, the vector B, it has a magnitude 20, okay? So let's get its angle from the positive x-axis. So if I start from this positive x-axis, I move like that until I meet this vector like that. So what is this angle that I've drawn out in yellow there, okay? That angle there will just be 360 minus this 20 here, okay? So that will mean that it will be 340 degrees. So that will be our angle for vector B. And then we can use that to resolve them into their components. Okay, so let's write it down and then we try to resolve these guys into their components. Okay, so we have this as that. Okay, and then we have the first vector here, which is A. So vector A, we're told it has a magnitude of 30. So you put your 30 here. And then the angle from the positive x-axis to here, we said it is 155 degrees. Okay. And then another vector that we have is vector B, which is here. So this vector B, it has a magnitude of 20 meters. So what is the angle from the positive x-axis here? Okay, the angle will be from here all the way up to here. And remember, we are the 20 here. So it means all this angle here from there all the way up to here is just what? 340. degrees. Okay, and now we can use these angles and these magnitudes to find the resultant. Okay, so the resultant, we just come up with a simple table here. Okay, so the first column here will be for the x component, and then this one here will be for the y component. Okay, so that is what we have there. So we put a vector A here, and then we put our vector B there. Okay, so this is what we have. Okay, so let's resolve vector A. Okay, let's resolve vector A. So vector A has a magnitude of 30, and then the angle that comes from the positive x-axis to where it is, it's just 155. So it will be 30 cos 155. Okay, so always, if you are in the x, it's cos. And then here it will be the same thing, but here now you have sine 155. Okay, so you punch into your calculator to find the actual value. You're going to have 30 sine 155. So you're going to get what? So 30 multiplied by cos 155. Okay, so I'm getting minus 27.19. Okay, I'm rounding it to 2 decimal places. What about there? Okay, I have 30 multiplied by sine 155. Okay, I'm getting 12.68. So 12.68 here. That is what I'm getting there as my answer. And then what about the B? So what is the magnitude of the B? The magnitude of the B is 20. And then we are going to say cos. The angle from the positive x-axis until we meet B is what? 340. So I'm going to put 340 here. And then here to be the same thing, but we'll put the sign now there. So it will be 20 sine 340. Okay, so this is going to be equals to, this is going to be equals to. So we go on your calculator, you punch 20 multiplied by cos 340. Okay, I'm getting 18.79. So this will be 18.79. Okay, and then here, what are we going to get? So there we have 20 multiplied by sine 340. So I'm getting minus 6.84. So minus 6.84. So this is what I have, guys. Okay, so we've resolved whatever we had into their what? Their components. Okay, and then now the question is we have to find, let me go back to the question. We have to find the direction and the magnitude of A plus B. Okay, so A plus B, what is the direction and what is the what? The magnitude. Okay, so A plus B, this is A here and this is B. So we're just going to add them, okay, to find our resultant there. So let's do that. Okay, so let's find our Rx, which is the resultant in the X component. So it will be minus 27 there. Okay, minus 27.19 minus 27.19, and then plus 18.79. Okay, so when I do that, okay, I'm finding minus 8.4. So this is minus 8.4. So this is what I'm finding. And then even here, let's do okay, so there we're going to say 12.68 minus 6.84. So this is going to give me 5.84. So I'm going to write my resultant y is just equals to 5.84. So 5.84. Okay, so this here is for A plus B. Okay, because we are just adding A plus B here, guys. Okay, we're just adding A plus B. Okay, so it means our a plus b has the x component of minus 8.4, and then the y component of 5.84. Okay, so now how are we going to find the magnitude? So remember, the magnitude is just equals to rx squared plus ry squared, and then we take the square root. Okay, and then the direction.
I have a question.
Yes.
Yes, on the x components here, when you did negative 27.19, you added with the 18.79, right?
Yes.
Then on the other side, are you adding or subtracting?
I'm adding. So this, because look, the first question here is saying a plus b. So I'm just adding whatever is in a plus what is in b. So you are adding 12.68 plus this minus 6.84.
All right, I didn't see the negative on the 6 point something. I sort of
Okay.
didn't zoom in.
Yeah. So this
All
here
right, thank you.
is going to help us find the magnitude, and then the direction there will just be the tan inverse of ry over rx. Okay, so this is what we have here. So let's find the magnitude here. So the magnitude will just be equals to this guy squared, so minus 8.4 squared plus, then on the other side we have 5.84 squared. Okay, then we have this to square root outside like that. So you just punch those into the calculator to be able to give you an answer. Okay, so my calculator is giving me, okay, so it's giving me the magnitude of a plus b will just be 10.2 meters. So this is what my calculator is giving me. And then what about the direction there? Okay, so for the direction, guys, always sketch your, okay, always sketch your ry and xy to know the direction that you are getting. Remember, the direction is the angle, and that angle should always be from the positive x-axis. Okay, so if you don't show it on a diagram, you just find an angle in another quadrant, which won't be correct. Okay, so we are going to get this minus 8.4 and this 5.84. We are going to plot them here. So if this is my x or y plane, okay, that is my x or y plane. I'm first going to plot this minus what? Minus 8.4. So minus 8.4, it means it's going to the negative direction like that. Okay. So here you just write 8.4, not minus 8.4. So the direction here is the one that's showing that this is negative. Okay. And then from this point, we are going to go 5.84 units up like this. Okay. So it means you join from where you started here to where the vector is ending like that. So the vector that we are, I mean the angle that we are interested in will be this angle, okay, from the positive x-axis all the way up to this vector there, okay? Then we know that this is 5.84. Okay, and then from here we can use this formula now. Okay, so you can simply use that formula to find your angle. So the angle that you are going to find, okay, the angle that you are going to find here, it will be the angle that will be inside there. Okay, it will be inside there. It will be the angle that will be inside here. That's the angle that you are going to find with this formula. But remember, we're interested with the angle from the positive x-axis. So we are going to say 180 minus whatever angle we are going to find here. So let's use this formula there. So it will be theta is equals to tan inverse of, okay? So when writing the ry, rx here, don't involve the negatives here because the negatives, you've shown them on the diagram here. So my ry is just 5.84. And then I'm dividing this by 8.4. Okay, so when you punch this on your calculator, what is it going to give you? Okay, let me punch this. Okay, so it's giving me 34.8 rounded off to 2 decimal places, it's 1 degrees. Okay, so it's giving me this as the angle. Okay, so this angle here, it means it's the one that is there where I was showing you. It's the one that is here. Okay, so as we're interested with this angle here, so what do we do to find that angle? We're just going to say the angle that we want to find is equals to 180 minus this angle that we are from finding. Okay, and then you punch this onto your calculator to be able to give you 145.2 somewhere there. Okay, so this is the direction that we are interested in. So we're going to say the resultant of A plus B. Remember, we're just on A plus B. I want to simplify this as simple as I can. So the magnitude, we found it was 10.2 meters. And then the direction from the positive x-axis is 145.2 degrees. Okay, so this here is the correct answer for A plus B. Right, so any questions from there before we go to A minus B?
So I have a question.
Yes.
Like here where you wrote, is it an inverse? Huh? And then in brackets 5.84 over 8.4. Wasn't 8.4 having a negative?
Yes, that's what I said. I said when you are plugging these values into this formula, always ignore the sign, because the sign, you've shown it on this diagram here. You've seen this diagram here.
Yes.
Yes, so by virtue that this 8.4 is going to the left like that, it means we've already shown the sign. Okay, so when you're plugging the values into this formula, to avoid complications, okay, because you don't want to get a negative angle here, you always ignore the sign. Okay.
So is it always are we always required to use a diagram like this one when you're trying to solve these such questions?
Yes.
Okay.
You use the diagram for you to find the correct answer.
All right.
Okay, now let's do A minus B. Okay, so we've done the first part. We found the direction, the magnitude of this guy. Let's do A minus B. So how are we going to do A minus B? So notice that A minus B is actually the same as, let me go back here. So when we have A minus B, okay, this here is just the same as A plus and then minus B in the bracket. So it means we are adding the minus of B to A. Okay, so which means when I go back to this table, okay, remember these values here that I have, this is the row for the B, right? These values that I have here are for the positive B. So if I introduce a negative here on the B, okay, it means this one here will become negative. And then this one already has a negative. So if I introduce another negative, it will just be what? Plus. Okay, and then we can find the summation of these y components when this b is minus. Okay, so I'm going to erase this. It's not the answer anymore because now we have made the b negative. Okay, so I hope you are seeing what I'm doing. If you're not, please ask. Okay, so I've added a negative to this b. So it means everything under b here changes. Okay, we add the negative. So here we have added a negative, this one, and then there it was a minus. We've added another negative, so it becomes a plus. So now find the sum of this. Okay, so we have now minus 27.19. Okay, and then we have minus 18.79. So when you do that, what are you going to get? You're going to get minus 45.98. So this here will be minus 45.98. And then here, what are you going to get? We just have 12.68 plus 6.84. So there now we have a 19.52. So we have 19.52. Okay, so this here will be the x component and the y component of, remember now we are finding what? A minus b. No wonder we've introduced this negative there. Okay, so let's get this and then try to find the magnitude and the angle using them. Okay, so let me find them. Let me find them from here. So we have this one, which is minus 45.98. So I'm going to write 98. And then we have RY, which is just what? 19.52. So 19.52. Okay. So the first thing that we're going to find is the magnitude, which is just going to be the square of this plus the square of this and then the square root, right? So it's going to be minus 45.98 squared plus 19.52 squared. So this here we are going to find what? Okay, so that's punch whatever you can see here on your calculator. Make sure that you put these brackets here. Okay, and then what are we going to have? So I have the square root of open brackets. I put the minus 45.98 close squared plus open brackets 19.52 close squared. Okay, so what I'm getting here is that okay, so I'm getting 49.95 if I round it off to 2 decimal places according to my calculator. So this will be the magnitude of the resultant A minus B. Okay, and then from there, let's find the direction now. So the direction, we are just interested in the angle. Okay, so I said for you to find the angle, always use the diagram because it will guide you. Okay, so if I write a diagram like this, okay, this is my diagram. So we have a negative on this x, so it means it's going in this direction. So this here is our Rx, so we can write minus, not minus. Those are the mistakes to avoid. So the minus is shown by the arrow, this arrow here. So we just write 45.98 here. And then from this head of this Rx, we go 19.52 up. Okay, so 19.52 up like that. So this would be 19.52. And then we join the starting point to the end point there. Okay, so we see that we are going to find this angle here. But our interested angle will be this angle. This will be our theta like that. Okay, so we are going to say this, which is the angle there, is equals to tan inverse of, okay, what is our y? Our y is 19.52 divided by our x, which is 45.98. Okay, so when you punch this onto your calculator, what are you going to do? Okay, so according to my calculator, I'm getting a 23. And then there are 0.0000, so I'll just write 23 degrees like that. Okay, but remember that is not what we're interested in, because that angle is not from the positive x-axis. Okay, so this one here will help us find our angle, which is this theta. So we're going to say theta is equals to, we know that if I start from here and end there, it will just be 180. So 180 minus this angle here, which is what? 23. So our angle there will be 180 minus 23 to give me 157 degrees like that. Okay, so that's how we find the answer there. So it means our resultant for A minus B now, okay, will just be equals to 23, not 23, what am I writing? 49.95 meters. Okay, and then the angle from the positive x-axis will be 157 degrees like that. Okay, so that's how we solve that one. So any questions there? Okay, no questions, right. So it means we can solve the other one. You can solve the other one on your own. So the other one now has this. Okay, so notice what it has. So this other one here, for you to find the direction, the magnitude, okay, notice that it is b minus a. So the minus is now on a. So this b minus a is the same as minus a plus what? B. Okay, so it means that row for a, you're going to add to my minus. Okay, and then this row for b, we are going to take it back to the positive one. Okay, so this is what I mean when I say that. So this here, this minus 18 was for minus b, right? And then this positive 6 point whatever was for minus b. So we are now finding b minus a, right? So this b minus a is the same as minus a plus b. Okay, so we'll make this b to be a positive again, and then we'll make this a to be a minus. So how are we going to make this be a positive? We're going to remove this minus, remove this minus, remove that minus there. Okay, so it means there we have gone back to having a minus. Okay, and then this one here is a positive, and then on the a here you add a minus like that. So this minus will come to this minus and they will form a what? A plus. And then here you add a minus, it will be a minus like that. Okay, and then you add them now for the b minus a. Okay, so for the b minus a, it means we can rub this and put the one for b minus a. Okay, so for b minus a now, it will be the following. So you just get your calculator and then you add. Okay, so the first one will be that minus 27 now is a positive, okay, because we have added this negative. So it will be positive 27.19 plus 18.79. Okay, so you're going to get a positive 45.98. And then here we have a minus of this, minus of that. What are we going to get? We're going to get 18 point something. Okay, so minus of 12.68 minus 6.84. I'm going to get minus 19.62. So notice that they have just switched the signs, right? Okay, because for a minus b, it was minus of this and then plus there. So b minus a is just positive here minus, okay? So you have your rx here and your yx, and then you can do the same procedure that we've been doing for you to find the resultant and the direction, okay? So that you can do it as your task. You can send your answers to my inbox. I'll be able to correct you. So we are done with this question 2, and then let's solve this last question here, which is on question 3. Okay, so question 3, we're still on resultant vectors, but now this question here is more of practical. Okay, so they are using a practical example just to confuse you guys, but the logic behind it completely the same. Okay, so they are saying 3 finalists in a contest are brought to the center of a large flat field. Each is given a meter stick, a compass, a calculator, a shovel, and the following displacement. Okay, so these are the displacement that we have. So we have some terminologies here that we need to interpret correctly. Okay, and then they are saying the 3 displacements lead to a point where the keys to a new building are buried. Okay, 2 contestants start measuring immediately. The winner first calculates where to go. What does the winner calculate in terms of the magnitude and the direction? Okay, so you've seen all this language here is just decorating the question. The question is that you have been given these vectors, okay? Find the magnitude and the direction. That's all, okay? All these words here are just decorating the question, just to confuse you. Okay, so this is a practical question. So it means these are the vectors that we're going to work with, and we want to find the resultant magnitude and the resultant what? Direction. So here there are important terminologies that we need to what? Interpret. So when they say 32 degrees east of north, okay, you always start at the very end here. So it means north is your reference point. So if I write my XY plane like this, we know that this is north. So this 32 degrees east of north, it means go to north, okay? So I'm at north, and then move 32 degrees to the east. So the east is there. So I move 32 degrees to the east, it will be somewhere there. So it means this vector here, the first one, okay, it will be here. And then here you have your 32 degrees Celsius, just degrees there. Okay, then the magnitude of this vector here will be 72.4. Okay, so I taught these terminologies. So if you watched my videos, you'll be able to know how we are coming up with this. Okay, and then even here, south of west, it means west is our reference point. So you go to west here, okay, and then from west, you move 36 degrees to the south. So the south is here. So I'm here west, I move 36 degrees. So it means 36 degrees will be somewhere there. Okay, and then the last one, they're saying 1.78 meters straight south. So straight north, south is the same as that language that we used to, when we used to say due south, due north, okay, it means you're just going in the same direction as the south, like that, okay? So these are the three vectors that we have. So we need first to resolve them, find their components, and then we can find the magnitude and the direction, okay? So I've explained how we are getting them, so I would write these now on the board, and then that's the question. Okay. So let's solve that question. So the first one, let's write them on the board here. Okay. Okay, so we have our XOY plane here. Okay, and then we have the following vectors. So I'll label these as north, east, south, west. Okay, so the first one was this guy here that was here. So we said this angle here was what? 32 degrees. Okay, and then the magnitude of this was, what was the magnitude of it? The magnitude was 72.4. Okay, so this is 72.4. Okay, and then the other one was here down. We're saying 57.3 meters. Okay, if I remember correctly. Yeah, 57.3 meters, 36 degrees south of west. Okay, south of west, it means west is our reference point. Then we move 36 degrees to the south. So this here will be our what? 36 degrees like that. Okay, and then our last vector was just directly in the south like that. Okay, so this here that I've drawn in red, they said its magnitude was 17.8 meters. Okay, so now we need to find the angles from the positive what? X-axis. Okay, so the first one there, it will be very simple for us to find the angle, because the angle from the positive X-axis to this vector here will just be this vector here. I mean this angle here. Okay, so how are we going to find this angle? We're just going to say, because we know that this is a 90 degrees angle, so it will be 90 minus 32. Okay, so this angle here will be 58 degrees. Okay, what about this vector here, the second vector? Okay, so we are going to come from the positive x-axis all the way up to this vector. So the positive x-axis is here all the way up to this vector. So what angle will be that? Okay, to just be, if I end here, I know that this here is 180 plus 36. Okay, so what is 180 plus 36? So you get your calculator, 180 plus 36, that's going to get 216. So in our resolving, we are going to use 216 degrees for this vector. Okay, and then that other one now, which is in the south, okay, we come again from the positive x-axis until we meet this red line. So we are coming from here all the way up to this red line. So what is the angle there? So the green angle there, okay, we know that if a vector is in the south, then the angle there is just what? 270 degrees. Okay, so someone might be wondering how we're getting 270. We said this one here is the 0, this one here is the 90, this one here is the 180, this one here is the 270, and then you come back here, this is the 360. Okay, so that's how we're getting the 270. So now let's find the components of this vector. So we have 3 vectors. Okay, as usual, you draw your diagram, couples of both are here. Okay, so you put your x component here, and then you put your y component there. Okay, so your first vector, we can name this vector here as vector A. Okay, and then the second vector we can say is vector B. Then the third one is vector C. Okay, so this is what we have here. So we have those like that. Okay, so now let's find these components. Find these components. So for A, the x component will just be 72, okay, 0.4 cos 58. Then the y component will be the same, but now with the sign, and then sine 58. Okay, so you can find the value there and you can find the value there. Okay, so when you punch that into the calculator, what are you going to get? Okay, so let's do that. So we have 72.4 multiplied by cos 58. Okay, so I'm getting 38.37. So 38.37. And then here, if I punch that one, it will be 72.4 multiplied by sine 58. So there I get 61.4. Okay, 61.4. Okay, let's resolve the B. So the B is this guy here. Remember, we are using this angle in yellow, which is the 216. So it will be 57.3 cos 216. And then here it will be 57.3 sine 216. Okay, so what are we going to find here? What are we going to find here? So you just get your calculator, you do the calculation. So 57.3 multiplied by cos 216, it's giving me a minus 46.36. So minus 46.36. Then here, what am I going to get? 57.3 multiplied by sine 216, going to give me minus 33.68. Okay, so minus 33.68. And then let's resolve the last one, which is the C. So the C is in the what? The direction of the south. So it will be 7.8 and then cos 270. And then here it will be 17.8 sine 270. Okay, sine 270 like that. So what are we going to find here and what are we going to find there? Okay, so 17.8, and then we have, of course, 270. Okay, so that will just be 0. And then on the other side, we have 17.8 multiplied by sine 270. It's going to give me minus 17.8. Okay, so this is what I get. So we can find our R here. So our Rx, we just add all these that we can see here. Okay, so when we add all those, what are we getting? Okay, so if I add these, I'm getting, okay, let me just add them. So 38.37 plus minus 46.36. Okay, I'm getting minus 7.99. Then on the other part, what is my RY? Okay, so if I punch this into my calculator, I'm getting 9.92. Okay, so we have whatever we need now to find one, the resultant, okay, distance or the resultant displacement, and then we also have whatever we need to find the angle. Okay, so let's find. So we are going to write these guys here. So minus 7.99 RY is equals to 9.92. So we have these. So let's find the resultant is just going to be equals to this guy squared. plus the 9.92 squared. So what do we have here if we do this? Okay, so if we punch in those, we are getting punching. Okay, I'm getting 12.74 meters. Okay, and then what about the angle? So the angle, as usual, we have to draw it. Okay, so if I draw like that, and then okay, so we have our x that goes like that, and then our y that goes like that. So this is 9.92, then this is minus 7.99. Okay, so this is just a coincidence because we are finding a similar scenario here, but sometimes it can be the x is going there, and then you have your y somewhere there. Okay, so it's important to draw. Okay, but for us, we've only experienced these ones in these questions we've been solving. So this angle here, okay, but our interested angle is this one here. Okay, so let's find this one here. So we're going to say this angle is equals to tan inverse of Ry 9.92 divided by Rx 7.99. Okay, so when we punch this onto the calculator, what do we get? Okay, so let me punch it. So we have shift tan, and then 9.92 divided by 7.99. Okay, so I'm getting 51.15. So this here will just be 51.15 degrees. Okay, but remember our interested angle is this guy here. So how are we going to get that angle? We are going to subtract from 180. So 180 minus 51.15 is going to give you 1. Okay, so 180 minus 51.15. Okay, so it's giving me a 128.85 degrees. Okay, so it means we have this as our magnitude and this as our what? Our direction. So magnitude will be equals to 12.74 meters. And then our angle from the positive x-axis will just be equals to 128.8 degrees like that. Okay, so we found the location of the keys. Since that question was practical about finding the location of the keys. So the location of the keys will be at this displacement and this direction here. Okay, so any questions there, guys?
Yes, I've got a question.
Yes.
As in, like, in which form is the calculator supposed to be set? Scientific or just at normal? The calculator, when I'm trying to do the calculations, is it supposed to be at normal?
It should be in degree mode. Because we are using it to find the degrees here, right? So your calculator should be on degree mode. You've gotten it? Have you gotten it? The one who was asking the question.
Hello?
Yes, hello. What was your question? I lost network.
Okay, I understand. My question was like, how are we supposed to set the calculator when trying to do the calculation? Is it supposed to be at normal or
Yes, just
maybe scientific or something?
No, put it in normal, okay, and then make sure the degree you put it in degree mode. So on your calculator somewhere you should see a D on your screen.
That's all.
Yes, that's all.
Okay.
Yes.
Thank you.
You only change your calculator to radian mode when you be doing circular measures. Okay, but that is in mathematics. It's not in physics. So in physics, chemistry, biology, just use the calculator at the normal stage and the degree stage.
All right.
All right, so any questions, guys, before I close the class? Okay, so thank you so much for attending, and those who want to register with us, feel free to contact me. Our tuitions are only going at 100 kwacha per course per month. Okay, so those who want to join our team, okay, starting tomorrow, which is 1st January, you are free to contact us. Okay, and then I think I have a question for you. Where is the question? Okay, yeah, this one here. So you can try out this question, and then you send your solutions. Okay, so you can screenshot, and then you try to solve it, and then you send me your solutions. I mark you. You see if you've understood whatever we were doing here. All right, guys, have a blessed New Year's Eve.